Okay, very good. On Tuesday, we talked about how we can make our input data acquisition foolproof because we thought we're writing real programs that will have real users and they can just mm, give us any input that they want, and this was our responsibility as the programmer to catch all the garbage that they might enter on purpose or by mistake most of the time. One part I we didn't have time to explain, so um, I'm going to show that to you today first. We saw how cin fails. Cin as an object fails sometimes, and we really discussed in detail when this cin fails. Same can happen to uh, output stream objects. And in output stream objects, we have cout, we have c error, cerr, and clog. So if something happens to cout and it fails, uh, what, for instance, it is a bit more less likely actually for cout to fail. But anyways, they have they have created, just like the cout we have two other identical to cout two identical objects to cout, that if something happens to cout and it fails, it can be, even it can be some problem with hardware, that it can fail, it cannot show the output, then the other two will work. So today you're going to see this mechanism that they have uh, for the other two output reporting, basically logging or reporting the error mechanism. So if cout fails, you can use cerr or clog, and this is how we're going to use that for clog now with this one. Uh, and by the way, it's a little bit now. What we're going to do now is a little bit more systematic way of showing the errors. The previous one, we were defining debug some boolean parameter. We were some boolean variable we were defining, and then if that was, we were, every time we wanted to uh, show show an error or show a message or show a prompt, we were checking if that debug is set. If that was set, then we will show error. If it didn't, we didn't show the error. This one that I'm showing to you, in this one we have main and we have the utils. In util.header, as you can see, there is no more extern boolean debug here. So there is no variable involved. And if we check the here the CPP file, util.cpp file, we also see that there is no variable defined here. So what we're going to do instead is a little bit more systematic way of uh, enabling and disabling basically debug messages. And uh, this one is like this. So in utils, instead of defining a boolean variable, I'm defining a boolean member variable for this guy and initializing that to false. Default for that is false. And then now we have to play around this member variable, and we have to check on this, and based on the the status of this mbog. If it is false, we'll do something. If it is true, we will do something. And also, we will be able to set this to false or true or false in our main program. So now that the first thing that comes in mind is, now that I have a member variable, uh, I should also have, these are from the past, like on Tuesday we talked about these. Now that I have a member variable, I should have a constructor, and this is simply, constructor can be, in this case, boolean, say what? Say debug, and we set it to false by default. And then also another uh, another function, uh, basically this will tell me, I'm calling this if debug. If debug, this will tell me if I am in the debug status or not. So let's call it, I mean, if the debug is turned on or not, based on the status of the mdebug. And finally, a setter allowing us to set this debug thingy. I can call it set debug. Set debug and put boolean value in it. Oh, let's set debug. Okay, now if we implement these for the if debug, I'm gonna simply return the mdebug, right? Simply return mdebug, and for the now for the set debug, let's first implement this. And for the constructor, we simply check if that value, or even not even, we don't need even to check, mdebug, set that to debug. Easy peasy. Now for the set, now the whole point of what we are doing is actually lies here. Now the whole point is that not only we should be able to set the mdebug member variable to true or false, but also we should have a mechanism to enable and disable showing messages. Since we are not going to write any if statement to check this, it's a completely different logic. I'm not going to check if mdebug is set to true or false. I am setting mdebug to true or false, so that my object status is, if somebody wants to know what is the status of this object in terms of debugging, this guy will tell them what the status is. The status will either be true or false. It will be either, depending on what this is, because this is returning mdebug. This will tell the user if the debug is on or off. But here, we are not only setting the mdebug for this query purpose, but also we want to enable clog as an object, enable that, make it work basically. If it is in a broken state, just like scene, if it is in a broken state, we want to make it work. And if debug is false, we want to kind of break it, so that it doesn't work. We want to do something that it doesn't work, and that something is like this. We can first, so now that this is the case, we're gonna check debug first. I'm gonna check debug, Um and so now if debug is uh, true, if this debug is true, this means uh, I am in the debug mode. So I want this debug to work. And we said that just like cin, the output stream objects also have this clear function which clears any flag that remains from the previous state. So by clearing this, I'm literally making clog work. And if it was broken, I'm resetting that, and I want this work. Why? Because now in this state, this actually, if debug is true, this means I want to see the debug messages, right? So that's why I'm clearing the the fail bit here. I'm clearing that in C log and making this work. Else, if debug is false, now we have to break this clog. How do we do that? This is how we do this. Clog.setState, set state, and in the set state, because C out, all these input and output objects are inheriting from the iOS, and the fail bit is defined there. I'm just doing this, and this will set the fail bit, and this will stop uh, uh, this clog from working. If you, instead of clog, it could be cout, it could be cerror, it could be any of those. So it works the same way. But I chose this uh, because my error message is printing with clog. And then once I'm done with these, in order to also set the mdebug to debug so that this query will work properly, I can say mdebug is equal to debug, right? I'm also setting, after I check the debug and do my stuff with clog, I set my mdebug and I'm done. And for any error message, now I have already added my error messages. In the case, the last case we discussed was detecting if a space or a new line or a tab was entered, and we said that we use peek to detect that, because peek doesn't swallow anything, doesn't consume anything, and just goes there and checks what's entered. uh, we do that. We use this. Otherwise, if we used anything else, and if the the first thing that the user entered was an integer, was a correct value, we would consume that. We would that would basically, after, if you read that, if you get character, like let's say get character, if you do anything else except for peek, that will clear that thing from the buffer. So the checking, basically the checking thing will result in losing that thing, and we don't want that happen. We want to just check and decide. That's where you use peek, because it doesn't clear and it doesn't swallow anything, it just checks on it, and that thing still exists there. So if it was a good thing, we wouldn't lose that. If it was like an integer, we wouldn't lose that. But here, last time we had cout. Now instead of cout, I'm using clog to show these error messages. And by using it, I don't need to check. If it was like a previous style, I had to check if debug, blah, blah. but I'm not doing that, right? We don't need it. It's a more systematic way of doing that. Clog will automatically stop working, will stop showing this if this thing runs, right? If where was it? We set that in the utils. We is in the utils we set that right now, right? We get int. Why don't I see it? Here. So if we come here, if debug is false, we will do this. So this will stop clog from working. So it will automatically not work. And if it is true, it will work. We can get our query. We know, and we know if we are in a debug state or not. In the main, so I need to come here and first set the status of my debug, if I want to debug or not. ut.setDebug, and I'm gonna set this to well, before that maybe I can just say it returns boolean, right? Cout ut dot if debug, see what is the status before doing this, and then I set this to true because I want to see the error messages, and run. Hopefully. Okay, so let's do this too. Okay, one more time. So before doing this, initially the the if debug is 0. So this is not in the debug mode. M debug is basically 0. Now I enter new line, or enter tab, or enter space, and I see these messages. Why? Because in this line we set this to true. Now if we change this and if we set this to false, that will result in clog stop working, and if I just press enter, there will be no error messages, and this way I will disable clog. Finally, if I enter a valid value, that will exit the code. This is a more systematic way of doing debug, basically making clog or cerr work or stop working by this mechanism that we just showed. It is slower, but this is a more systematic and a more preferred way of showing error messages. Okay, now we are completely done with the I/O and everything related to that. If there is any question, please go ahead and ask. Otherwise, we're gonna jump into the concept of function templates. Okay, any questions? Let's do it this way. Any questions? Okay, great. Now let me close this and open another project. Okay, so this is about function templates in C++. Before we start, what template brings to mind is something very generic, right? When we talk about templates are something very generic that uh, allow different staff to use that very generic style to make a real thing. That's what a template is, right? In C++, template is also like that, and this is very useful. This is the ultimate art of C++, and this basically saves a lot of coding for coders when the logic of the functions are the same. We will see now. For example, let's start with an example. If I define a function here, sum int a and int b, simple, int a and int b, and here I just return a plus b. Should probably be the simplest function I could write. And in the main, I come here and say, okay, now I want a be 10, and I want b be what, 20, and I want to show say what, c is equal to sum of a and b. I guess you all agree with me that if we run this, we will see using this function, the result will be 30. Super easy, nothing complicated. Now imagine I did this with integer. And now somebody comes and tells me, okay, the input might also be double, for example. Why not implement double? Okay, I go ahead and say, okay, double sum, double d, and double double e, and do the same thing. Return what? D plus e. That's what it will return. And here then I'll be able to say, okay, now I define two doubles, double d. I want d to be what, 2.3, and define e to be 5.8, and then go ahead and do the exact same thing. Do this and say now f is equal to sum of d and e. This is the exact same logic. The only thing that is different is instead of integer I have double. That will obviously work the exact same way for me and will show me the result. Now, if I take one step further and say instead of int and double, what if I have a class named population, for instance, and this population of mine has a member variable that keeps the population. So let's say city P has 10,000 people living in there, and Q has 20,000 people living in there, and I want to show C out sum of this P and Q, and that's it. So for this one, I should go ahead and write another sum, because these two sum will not support that, even though the logic is the exact same thing. But instead of this, I should come down here, probably because it's the exact same thing. You will say, okay, I just copy and paste and change this double to population. Now it should return population, and in the input argument, I'm gonna pass population instead of double, population, and I'm gonna put P here, I'm gonna put Q here, and I'm gonna say P and Q. This will be the population. Now the only thing that remains is the definition of this class population. So for that, we can easily define a class population. You can say class population, and we said that this has an integer that keeps the population, and in the public part, we should have the constructor, right? Because we have the member variable, we should have the constructor int value defaulted to 0, and use the initialization area style to initialize this to value, and just do nothing. That's my constructor. And then what else do I need for this to make this work here? See, now this sum of mine returned population, just like this sum returned double, and this sum returned integer. This sum here returned population, an object type population. So first of all, for this to work, if this is C out, if this is C out and this is population, shouldn't I have insertion operation overload? I guess I should have. And apart from that, what else do you think now my class population should have to work within this structure? Just unmute and let us know what you guess, what you think. I revealed one of the things that population requires. That's the insertion operator overload. Otherwise, this would be meaningless. What else? Like, what do you think if we not implement, it won't work? Is the question confusing? Is so answer this. Is the question confusing? Okay. All right.
Operator plus. I'm just kind
Up.
of guessing there because it's giving you a.
That's right. That's right. That's right. A good guess. So Sebastian said yes, it's confusing. Sebastian, look, I said the question was, now for the integer and double, we didn't have to implement this insertion operator because this is already implemented in the cout object. If on the right hand side of the cout there is an int or double, cout knows what to do. But this is not the case when I have a custom class named population. That is my definition, that's my class. First thing that I need to implement is the insertion operator overload, so that cout, when cout sees a population on the right side, it knows what to do. That was one of the things. The other one is this P and Q. See, now after this insertion operator overload is done, then the compiler will come here. We'll say, okay, sum of P and Q. Okay, we'll look for the type. We say, okay, this is the function. And now return P plus Q. P is population, Q is population. How am I gonna do this? Unless you also have implemented the addition operator overload, right? So these are the two requirements for the class to work within this notation. So let's go ahead and implement this class. I hope it now makes sense. If not, don't worry. We will see more of this and we will discuss all these things. So for the population, then we said that constructor was a must, and then for the population, I'm gonna implement an operator, uh, operator plus overload, and it will be just constant population reference P, right? And then here constant. And here we just say what we need to do here is to add the m value of the right side to the m value of this current object. So we can say this m value must be what? This m value, this m value plus p dot m value, right? And this will be our operator overload, and here I should return this, right? And then put some space, and then in order to be able to implement the insertion operator overload, I first need to implement a display function, display ostream reference ostr cout, and it is constant, right? And here we can just say cout p is equal to what? m value, and return ostr. And then finally the insertion operator overload here, again ostream reference operator and ostream reference ostr and population reference p, and here we can simply say return p dot display. Now with this mechanism, display, with this two things that was required for my function, now population in the same way. Why is it giving the error? Build. No operator matches these. What run did I make? Same operator, population reference. Some. Okay, I think for this is now population, and some should return what? Some is returning population, uh, and here this should be for the operator. It shouldn't be reference. Is that right? Yes. So the problem was actually it was good to notice. The problem was sum is returning population. So on the right side of this operation, this insertion operator overload is not the population reference. It's the population by value. So I have to put this population by value here in the operator. So if we run this now, there we go. Now it is the exact same thing that happened to integer, double, also happened for the population, provided that I correctly basically define the requirements for this in my class. Now, if somebody comes and tells me, okay, now instead of population, I want to have what? I want to have the exact same class, but not population. This time something else, like army. Now, now I want to have class army. Want to have class army. This is army. This one is correct. This one is army and army, and this one is where else? Also here, this is army. Now with army, I want to be able to do this, and here, same thing, army. Put here instead of this. Now I have a small army of 500 soldiers, and I have another one of 1000 soldiers, and I do this instead of P and Q, say now A and B, here B, A. And this should do the exact same thing. I didn't implement sum, so here is the sum for the army. This is the whole point. Now for every single type of uh, uh, every single type, we have to come here and define the sum army, define the sum function for that, for it to work. And if I run this, it will work the exact same way. Now, how much redundancy do you see in this thing? This is, we have implemented for the sum function. When you look at this, it all looks like the same. The logic is same, everything is same, except for there are different types involved in this sum, right? Other than that, everything is it is sum returns a type, and the input arguments are two, and both of them are the same output type, and then we are returning something by doing this plus operator. So why not make a template for this? Now this is what brings to mind is that now template can be useful here. How? If I just come here and say, instead of all of these sum functions, right? What if I define a template? This is the important part. Let me check if you can see this and it's recording. From time to time I check. This is template. I'm defining a template now, and type name, type name, type, or whatever, t, t. This is the placeholder. So the idea is this. Okay, now what if the idea of the template is, what if I don't put real types here, but instead I put a placeholder and then ask the compiler to fill in that placeholder for me and make a real function like this. This way, I can look at these. I can put a placeholder instead of int here. I can put a placeholder instead of double. Everything. If I just put a placeholder, if compiler understands from what I put here, if the compiler understands what type of input argument I have, output is the same type, so this will just fill in that for me and life will be much easier. So instead of army and population and double and int, I just here put this placeholder. Sum is sum. In the int, again, instead of this army, population, int, and double, I put t, a, which is the input a with type t, which I don't know, is a placeholder, will be completed later by the compiler, not by me. T, b, and the rest is just history. Return a plus b. And this will be the function template, for my sum. What now if somebody comes here and adds 1000 different classes, I don't need to repeat this sum with the exact same logic for all those 1000 functions. I just put the placeholder. The only thing is that now let's see if it works. um, and I am commenting. So there is no sum function of specific type except for one sum function as a template with placeholder for its inputs and output. Now let's see if it works the same way it worked in the past. Yeah, it works the exact same way. Now this is a big, big save of time and code. If you're loading this to a small, tiny microcontroller, that's a save of memory, save of space, a lot of efficiency and good things that this brings with it. So we basically rely uh, on the intelligence of the compiler. So what happens here is when we do this, compiler comes here and says, okay, now I have a sum function with input a and b, and these inputs a and b are defined as type int. Then goes looks for real functions. It cannot find any function with int type as its output and input, but comes checks the well, actually this is a good point. You should know functions with functions with specific types have higher priority than templates. If your compiler goes and doesn't find any function with the real type, then it comes checks the template parts. In the template parts says, okay, now sum is here, and instead of this t, I see that this is int, this is int, so this is also, this most probably this should be int because this is what the template is saying, and puts there, and from this template builds this function basically first in the solution. It builds this function and then uses that function to execute this line. This is the whole concept of template with a with one simple example. Does this make sense so far? Yes, 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 yes. Very good. Now, sky is the limit. You can take any function that you write. You can take it if it is something that is repeating uh, again and again in your project, or if it is repeat, it's something that you want to use as a tool. But you know that the logic of that function basically will repeat, but that function might be used with multiple different types, then template is the solution. You make a template for that logic, and instead of the specific types, you put placeholders, and the compiler will take care of that for you. This is the concept of function templates, and now we will see more examples. One thing that I want you to consider uh, as a very, very important part of making a template is that you should document your template for the person that wants to use your template, or for yourself when you come after 2 months. What is documenting? Documenting is the thing that I asked here. What do I need? The question was, for this to work with population, we saw that it worked with int and double. For this sum to work uh, with the population, what is a must member function for the population for this to work? The must member function is the operator plus overload. So you should write here for the users of your template, um, objects, or like classes must have operator plus overload to be consistent with this template. This is the only thing, right? Because here I only have a plus operator. Another thing that we had to use was because of the cout thingy, like the insertion operator overload, was because we had the cout thingy here, so that population must have. But this is not necessary to be in the document. Why? Because this is what the user is doing. Main part is what the user is doing. You're not responsible for what the user is doing in main, right? They know. They probably know if they want to implement this. They probably know their class must have the insertion operation overload. But what they maybe don't know, uh, if you also hide the logic, you just say, okay, give me two things, and I will add them up and will return to you. So you should specifically tell them uh, what operator overload, or what other anything, can be anything, copy constructor, whatever. What is that thing that is a must to be in your class for that to be consistent with this template and to work? Uh, is this clear so far? Okay, very good. Now that it's clear, let's see some more examples from this operator overload. Um in your what in your workshop 9, you saw, or you, if you have not done that, you will see that there is a sort function. So this sort function, now we are going to write it here and analyze and do good things with that. Yes, please save. Save. Okay. Imagine I have an array. Uh, I have an int array uh, of these numbers. What? These numbers 2 and 4 and 3 and 5 and 3 and 4 and 6 and 7 and 8. Okay, and I want to sort them in a descending fashion. For that, we had this bubble sort algorithm. You can see uh, in your workshop 9. But let's a little bit understand the concept here. For many people, you may already, maybe you know this, but just to make sure we're not missing anything. So imagine this is my example. I want to sort this in a descending fashion. Now it's ascending. I want to sort this to descending. What I do is, in this algorithm, first start with the first two in two basically nested for loops. We do this. The I is the counter for the first loop, and j is the counter for the second loop. And the algorithm goes like this. First, look at the um, first two places in your array. Then, if a0, because we want this to be descending, if a0 is less than a1, then swap them. Then come to the step 2. In the step 2, I is still 0. We increase the j. For j, again, do the same thing for the next two places. Swap them if the one on the left is less than the one on the right. And then again, I is still 0. We first sweep the whole array from left to right. Do the same thing here. So this is the result of the first round. This was the original array. This is the result of the first round of sorting. Obviously, we need more sorting. Where? For the other, basically the first three. Now with this one, we make sure that the last block is keeping the value that was minimum. So increase the I. Again, start from j equal to 0. The first two, check this, and still I is 1. For j equal to 1, do this. Now we're done with the second loop as well. And the last one is, if we do this for the last one with I equal to 2 and j can only be 0, then we will sort this. Now this code that you have in workshop 9, and I'm going to write now here to write it here now, is the same thing. So for sorting these, we are basically saying, okay, void sort int integer. First it gets integer integer array and integer n, and this n is the size of my array, and then int I and j, both of them 0, and then the first loop is for I equal to 0 until I is less than n, and n being the size of the array. So in the PowerPoint example, we saw that this n was 4 for an array that is keeping 4 things in it, 4 integers in it. And this one come down here, the second loop for j equal to 0 and j less than n minus I minus 1 and j plus plus. Now do what? Do swap the two things. When? Uh, if array, if this array j of mine is less than array j plus 1. Why less than? Because I'm doing descending order. In this case, swap this. Swap what? Swap uh, array j and array j plus 1. What is swap? Okay, I don't know. I'm gonna implement it here. For swap, what we can have is void swap integer pointer a and integer pointer b, and here say integer a temporary integer. Now we'll keep the value of a, right? On Tuesday we said that when a pointer already has one asterisk sign, when you add another asterisk sign, it changes from pointer to value again. It brings the variable back to the world of values. Now the value of a, I'm gonna say that I'm keeping now b in a. The value of b goes to a, and the value of b becomes temp, right? And this is how swap works. So basically you store we define a temp, and in that one we keep the value of a, we copy b to a, and b then takes the value of a, and this way we swap these two. And also now it should be good to say that, to come down here and say now sort a and how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. Okay. Sort them. And I need a print function to be able to show these, right? So let's say this also, let's write a print function. Print, and in this print, again, I'm sending an integer array and an integer number, an integer value that is the size of that array, The problem that we in C and C++ we usually have is that the size of arrays are the compiler is not typically aware to the size of the array. So we don't want to get into complexity of those, and we want to uh, simply pass the size uh, in this case. So that's why I'm also including that. Obviously, there are many other ways, but to make it simple, because we're not talking about arrays here, we're talking about templates. So just make it easy. N I plus plus. Now I want to print every single one of these if I see out. Now I'm taking care of those commas. Uh, Print this and this. This basically, this will skip the comma before before the first first element, and then say see out array I, see out array I. And here I can come down after the sort and say, okay, now I want this to print a and 9, right? Easy peasy. Let's run this. What is the problem? Swap not found. Swap uh, swap identifier not found. Main line 8. Main line 8. But I have swap here. What else? See out undeclared. Am I using namespace? Using namespace std. We build this now. Cannot convert our integer pointer to. Okay, apparently the problem is here for the swap and for the function array j and array j plus 1. I'm swapping these. This one is correct, and in the swap, so integer pointer a, integer pointer b, swap, right? Why didn't it work? One more time. What is wrong with this? Print is there. A array is there. When std swap, send the ty reference non-expected. Cannot convert argument 1 from int pointer to reference. It's the same thing. Uh, swap and j plus 1. Where did I make a mistake? Pointer Do you guys see any mistake?
I think you may try to bring the swap function definition before the sort function.
Exactly. Thank you. Okay. Yeah. So we see who noticed that I missed you, sir. Who was that?
Oh, it's me, sir.
Tran. Thank you, Tran. I
Oh,
I
you're welcome.
I wouldn't find because I was thinking about million different things that, but not this one. Thank you so much. You saved me. Okay, so now we see that it worked. One more time. Not here. Sorry. Okay. Oh, sorry. Okay. Sorry, I refreshed this by mistake. Okay. Now here, if I run this again, we will see that this array has been sorted properly, right? This array has been sorted properly. Now, again, in the same, sorry, in the same fashion, what if somebody wants to make this with double? Okay, that should be possible with just converting these to templates. What if this was double? If it was double, let's copy paste this, but we're not gonna complete that. In this one, let's make it a template now, huh? What do you think? Let's make it a template. Now, I want to be able to sort not only integers, but also doubles. So for that, I can make this a template, say template for the void template type name t. It can be anything, by the way. It can be whatever you like. I'm writing type. Type, and now we have to go ahead and change the int things here to type double. What if it was double? If it was double, this void wouldn't change, but this int would simply be type pointer, right? And here this integer would be type. Now, because I want to make it a template, these are the two changes. How about this int? Do I need to change this to type or not? Can we make a poll on this? Do I need to change that? Uh, do I need to change this int now to type or no? Okay, good. Yes, exactly. So this needs to also be changed to type, and there is nothing else. So I changed this to type. Uh, so now it's a template. I can get rid of this. Comment this. Now we should be able to see the same result uh, with int. It should work properly. So the template worked. Now let's make a template out of it, out of this sort. To make this, again, we add template, type name, type, and here, now, tell me if this one should change. Should this change? Yes or no? Should I change this one to type, this int to type? Yes. Okay. Thank you. I change this to type. to type. This I shouldn't change, right? Should I or I shouldn't? Should I change the second int? Should I change this one? Uh-huh. Yes or no? That's right. No, I shouldn't change because this is the number of elements in that array, and it's not related to the type of those. So I'm just keeping this. What else? Here, no change, right? Whenever you disagree with me, just let me know. I'm not gonna change this, and the rest looks good to me. So when we created this template, we can simply comment it out and test again. Integer works perfectly fine with this template. And now for print, again, we can have, and we should have our template for the for this one, template uh, type name, uh, type name, type name type, and now here this one should change to type, right? And what else? Nothing else, right? The only thing that had to be changed was this type for the array, and now we comment this out, and this should work properly for the integers. Same thing. So I was able, because I wanted to test another type here, which is double, I was able to change the logic to a template. Now I don't need to repeat these things. I can simply come here and say double, double B equal to what? 2.34, 6.8, 1.20, what, 4 point something, 4.98, and 10, sorry, 10 point, what, 67, something like this. So how many? 1, 2, 3, 4, 5. And then here say sort, again using the exact same sort but in the form of the template, and print, use the exact same print with no difference in the form of template. Now I'm good with this, all the sort, print, and okay, so let's do this. Print in print, after this cout and L, and do it here, and okay, now if I run, we see 10 point, we see 10, oh what, why did I put 9? It's showing garbage. 5, one more time. Here 10.67, and it is sorted in a descending fashion, right? So now imagine this template saved us a lot of time and a lot of space. Now one interesting thing, when I by mistake I put 9 there, and we see some stuff. You guys know what these are, right? these are some random values that are outside of our array, but one of the strengths of C++ and C programming is that uh, it is blind to the size of the array, and whatever you say it will show, but it can show some garbage because uh, these are not in our array. Just to explain what those things were, and we're good with this. Now, uh, okay, it worked perfectly fine. Uh, is this okay so far? If there is any question, please go ahead and ask. If not, I'm going to do this. Now, we did the same thing for int. We did the same thing for double using this template, and everything worked properly fine with just templates. What if, let me get rid of these. So you see that these are all functions. These are all templates. So I just clean these. Now, what if I want to test this with a class? Now, let's see if I just bring one of those classes that we had in the previous one, like the population. Will that work? Let me bring population in. Population in this one. Population, class population. I'm just copying the exact same class population here from previous example. Um, and then do this and then do this. Okay, what do you think will happen? I want you to think about it for a minute, and then I will ask the question. The question will be, will this work or not? So now I have these. I want to do the exact same sort type thing that we did with int and double. Now I want to do that with the population, and obviously I want that sort thingy sort my population, whatever number I have for the population. So basically I want to do this. Uh, I want to do this. I want to come here and say if I define uh, an object population, p something, and put there what 1,000, 2,000, 5,000, and 500. Now I want to be able to say sort p and what 1, 2, 3, 4 and 4, and I want to be able to print that. Print print p and 4. Now, will this work or not? I will show you again. First, sort. For the sort, look at the things that my population class requires for sort thingy, and look at the thing that print requires for sort, because now population is a customized class that I am defining. Do I need to add anything to the stuff that population had before or not? Now that you are thinking about it, let's make a poll out of it. Is population as it is enough and consistent with these sorting, and obviously you should look at swap as well, because sort will call swap. Sorting and swapping and printing is what I have as it is good and consistent with these? Will I see a sorted population or not? Yiliu says yes, Tran says yes, Katlin says no, Armando doesn't say anything. Katlin, why do you think it is not enough? What do you think is missing?
I'm not sure, but maybe the comparison operator.
You mean this one?
Yes.
Exactly. That's a exactly. Thank you so much. That was 100% correct guess. Now, if I want to, now look at this. Uh, this here, this will be a type what? A type population array. How do I know for a type population array if this population I is less than population I plus 1? How do I know that without a comparison definition? So that is one of the things, because of this template, that is one of the things uh, that our class must have. So I'm adding that here. A classes must overload this less than operator to be compatible with this template. Great. How about, do we need anything else? Type, this wasn't sort. How about here? Do we need to add anything here? Now imagine A and B, here, A and B are type population, are not simply integer array or double array. Do I need to add anything or not? Yes or no? Tran says yes. Kathleen says no. Other people are still thinking. So now that Tran, you said yes, what is that I should add?
So I think we have the equal operator here. So we should have some sort of like overloading operator equal for the type.
That's a good guess. Let's see. Let's run this and let's see, because now that's a tricky thing. I will explain. Uh, Here, uh, for the classes that uh, do not have resources, basically the comparison can take place automatically by comparing their member variables. The the copy assignment operator, or this one, no, this is actually uh, we're assigning, right? this can happen automatically for classes that do not have resource. So if you write it, that's fine, it will work. But even if you don't write it, it will work. If this was we will actually see next session. We will see this when your class has resource, when this thing is dynamically allocated. In that case, you must have the assignment, the copy assignment operator, and obviously it's among the rule of three, and you must have that, and this will also work. But here, by just simply coming here, let me first run this. Let's see what errors we will get. Thank you both, Tran and Kathleen. See, the only error that we get here is this less than operator is not defined for the type population. So what I'm going to do here is go ahead and in population, I'm gonna say this should be a boolean output, because this is in the if statement, right? Operator, and this less than basically can only return the boolean. It could be, come on, operator, that's right. Operator constant population reference q, and then here I'm gonna say return if m value is less than q dot m value, right? Now that we have this operator overloaded in our population, let's see what happens. It worked. It worked, and it worked properly. It set 5,000, 2,000, 1,000, and 500. So Tran had a good point actually, but since for classes that there's no resource involved, this copying can happen automatically by the compiler. There is no problem for that. I think we have also seen this in previous examples. So try at home. Again, try it and see if you implement a class that doesn't have a resource, just like the one we have in population. See if you can automatically assign one population type value to another population type value. But it works. And this way, we were able to basically sort this population using just these templates. So for today, I think from the concepts and examples now, we learned about this. For the next session, we'll see one example of this with a class resource, with a class that has a resource, and we will see how we should implement that. And after that, we will discuss class templates. Class templates are the final topic that you need to know. And if we have time, we will go over uh, just a 5 to 10 minute discussion about different type of polymorphism that we've seen so far, and that will wrap up everything. I was thinking also about having a session uh, to just discuss what can be what will be in the final assessment exam, but after that, so maximum 2 sessions we will have, maximum. It can, I guess it can even be one, but in two, we consider 2 sessions next week. And then the week after that, we will not have lectures because there's nothing remaining, all the things. But I will be available. You can send your questions on Teams to me, and as usual, we will go ahead with all these stuff. So, in summary, for the templates are function templates are functions with the exact same logic where they can be implemented with different types, and for that type we just find the type, and instead of that type uh, we put a placeholder, and that placeholder can be anything. And by doing that, we just have one template that compiler can look at that and generate the functions with real types. Easy and very useful. I don't have anything to to discuss for this session. If you have questions, please go ahead. Uh, Otherwise, we can end the session. And I'm regularly uploading immediately after class. I'm uploading the codes to our second half of the semester Git repository that you all know, and you can always watch the videos on YouTube or on Big Blue Bottom. Okay, any questions? If not, I'm going to end the meeting. Okay, have a great weekend. We'll see you next Tuesday. Take care.
Thank you. Bye bye.
Thank you, Tran. Thanks everybody for coming and listening.